Next, we're going to take a look at inverse variation, and then we'll look at joint variation. So this example is the relationship between the volume of a gas and its temperature and pressure. So reading this first sentence again, the volume varies directly. So volume equals the constant of variation times, whenever it's direct variation, you multiply it by the constant of variation. If it's inverse, it's divided by. So it goes in the denominator. So varies directly as the temperature, and inversely, so this is going in the denominator, as the pressure. That's our generic equation. We're going to substitute in to find the constant of variation. We know the pressure is 0.75. We're looking for that constant. 294 is the degrees Kelvin, and the volume is 8,000. So when we multiply both sides by 0.75 to get it out of the denominator, we get 6,000 equals 294 times the constant of variation. Dividing both sides, we get a constant that's about 20.408. So when you're rounding for this class, keep it to 3 decimal places. So our generic equation, going back up, all we're doing now is we're going to take this equation and substitute the constant of variation. Using this equation in part B, what is the pressure when the temperature is 300 Kelvin and the volume is 7,000 cubic centimeters? So we know the volume is 7,000. Constant of variation we just discovered. Temperature is 300. And we're looking for that pressure. So when you're solving an equation and a variable is in the denominator, you multiply both sides to get it out of the denominator. So we've got 7,000p equals 20 times 300. And of course I didn't evaluate that, so I'm just going to keep writing it. And then we're going to divide both sides by 7,000. So our pressure is approximately 0.875. Always label your answer kilograms per square centimeters. Last example, we're looking at joint, and it is interest on a savings account. So interest for a savings account is jointly proportional. What that means is that we are multiplying these two pieces together. In this case, time and principal, which means the initial amount invested. After 1 quarter, the interest earned on 5,000 is $43.75. Now part B, the question is what's the interest after 3 quarters? By the way, a quarter is a quarter of a year or 3 months. If part B was asking about time in years, so if it was what is the interest after 3 years, I would use 1/4 for the time to solve for the constant of variation, but because the units are the same, I can use 1. So my interest is $43.75. I'm trying to find the constant of variation. The time is 1 quarter, and the principal was $5,000. Again, if the application piece is asking for time in years, I would use 1/4 for 1 quarter. Dividing both sides by 5,000, my constant of variation is that. Writing the equation, going back up again, this generic equation, all we're going to do is replace the constant of variation times time times the principal. And then we can use that equation to answer our question. What is the interest? So I is what we're looking for. After 3 quarters. 3 quarters, we're substituting 3 because we used quarters as our time in the first one. And we're talking about the same account, so it still has an initial investment or a principal of $5,000. Multiplying all of those together, we get a total interest of $131.25. And of course, your U-try problem as always.